Hello, everyone. We're going to do a brief review of the scientific method and cognition. We're going to do this. We're going to try to go through this quickly because I know you've probably had methods if you're in this class, but this is mostly just to give you a brief reminder of what we do in experiments and why we do it that way. And then when we go through some of the experiments that we'll go through in this class, you'll be able to see the ways in which much of the scientific process was either broken or not realized fully, and what that might mean in terms of implications for future research. So when we talk about studying social psychology, we're talking about using behavior. Remember, we spoke about that the other day, to predict affect and cognition. So using observable things that a person does to predict what emotions they're feeling or will feel, and what thought processes or evaluations a person is making. Hypotheses lead to observations, which leads to theory. So an hypothesis is an educated scientific guess based on what you have observed and what you think will happen. But I said that in a not good way. Hypotheses are educated guesses of what you think will happen. These lead to you collecting data, the data based on what you predicted would happen. And then the data lends itself for you to either add to or reevaluate the theory which led you to getting your hypothesis in the first place. That hypothesis that you got is based on some theory of how the world works. And from that theory, you're deriving an idea of what you think is going to happen in the experiment that you're running. But you need data to either confirm or disconfirm that hypothesis. That's a much better way of saying it. A theory. We can define a theory as an integrated set of principles that describe, explain, or predict some aspect of the world around us. Describe, explain, or predict some aspect of the world around us. Theories test hypotheses. So from the theory, a hypothesis is derived, and we test that hypothesis to figure out where it fits in the overall theory. An hypothesis, then, is a prediction about what will happen in our experiment under certain circumstances. Based on what's going on in our study, this is what we think will happen. An example, people with low self-esteem will be less likely to self-enhance than people with high self-esteem. People with low self-esteem will be less likely to speak to their own strengths, talk about how good they are, versus people who have a higher self-esteem. We talk about research, there's observational research. So research in which we simply observe what someone is doing in a natural or artificial environment. The environment could be artificial because perhaps we're observing what they do in our laboratory. Well, our laboratory doesn't always resemble the real world, even though oftentimes we will work very hard to try to ensure that it does, but sometimes it doesn't. So we observe people perhaps in their home. So we observe what people are doing, and then we make notes about it. Now, I got to stop here for a second and pause, because hopefully what you remember from your methods class is that people change their behavior based on knowing that they're being observed. If you say, Dr. Sims, is going to come into my house and watch what my family does, just by nature of me being there, even if I'm quiet, even if I'm hiding in the corner and you can't see me, just by knowledge of the fact that I'm there, your family is going to act different. So observational research has limits because people change their behavior based on the presence of an experimenter. So in observational research, then, we are observing people as up close as possible in their surroundings. For archival research, we are analyzing social behavior that's been documented in past records. Perhaps I want to look up past records and try to figure out how long people courted in the 1950s before they got married. Perhaps I want to look up our archival data from churches to see and to track how many people attended church on Sunday. Surveys. These involve asking participants questions, usually through some type of interview or questionnaire. Oftentimes, I can take the survey and mail it out to a large group of people, and then a few people will respond back, and I base my findings on those people who responded back. Surveys, it's important to consider the number and type of people who are surveyed. Survey results might be limited if the sample is biased. I pause here because it's important to realize something about surveys. And the thought process is there is something particular about the people who return surveys. There's something about those folks that separate them out from the people who get surveys in the mail and then just trash them. So the sample could be biased based on the fact that the surveys have been returned. Surveys can accurately represent a population from a relatively small sample if the sample is unbiased. If I can get random sampling or a good, adequate sample of people to return their surveys, then it can tell me something about the population at large. We're going to go through some basic definitions quickly to remind you. Hopefully, this is review for all of you. First, there's the population, the complete set of individuals, objects, or scores. I do a study, and everybody in Dallas, Texas is a part of the study. Parameter, a number calculated on population data that quantifies a characteristic of the population. Suppose I wanted to know what everybody in the population did. Whatever score that is would be a parameter. So the parameter is a number that describes the population. Sample. A sample is a small subset of the population. The sample is small, but it's representative of the whole. The sample tells me something about what is likely to happen in the entire population. The statistic. The statistic is the number that's calculated on a sample that quantifies a characteristic of the sample. What if I want to know what the average number of the sample does? That average number would be called a statistic. So if I'm talking about a population and I want some number derived that tells me something about the population, that's a parameter. If I'm talking about the sample and I want some number derived that tells me something of the sample, that is a statistic. There's the mean, which is the average score of everyone in the sample. There's the median, which is the midpoint distribution. It's the value where half the scores in the distribution fall below and the other half fall above, to the exact midpoint. The mode, the most frequently occurring value in the distribution. The mode is useful because it tells us what score is frequently happening. And that tells us something about the sample. There's correlational research. Correlational research you probably remember from your methods class. With correlational research, I know I have a lot of words on this slide. The main thing to think about is when event A happens, to what extent can I expect event B to happen or to not happen? So in what ways is event A associated or not associated with event B? Things that are related, for instance, height and shoe size. The taller you are, the larger shoe size you tend to have. Mood at different types of the day. You might be unhappy in the beginning of the day as you wake up, and as the sun begins to shine, as the day begins to progress, you tend to become happier. Football game wins and team merchandise. Let me tell you right now, it is very difficult to get some jerseys for the LA Rams. It is very easy to get jerseys for the Houston Texans. And it is very easy to get discounted jerseys. You want to go to a football game right now, you can pay $20, and that will get you inside of a Houston Texans football game. You can't even really get into California for an LA Rams game for $20. So the more success, the more storied that the franchise is, the more merchandise that's sold, and the more expensive the merchandise tends to be. Remember, correlation does not equal causation. Seeing a correlation is simply a statistic which tells us the likelihood that things are associated. But we can't say that the two things caused one another. We can't say that the two things caused one another. However, correlational research is a good starting point. It's a good way to point to possible causal relationships that we might have missed. And sometimes you can't assign people to conditions. Some people either are 6 feet or they're not. I can't assign you to the 6-foot condition if you're only 5 feet. So correlation is a good way to look at variables for people as they are to get an idea of what it is they might do. Other things we can assign: gender, SES, age, harmful long-term effects of a treatment. If we have a treatment that we know is could potentially cause serious side effects. You remember our lecture on ethics. We can't keep people in that position for a very long time. Can't do it. So some examples of correlational research. People who watch evening news tend to see more danger in the world. That actually makes sense. I actually stopped watching nighttime news because when you turn on the news, what happens? The first 20 minutes of the news is like people who got murdered, mass shootings, robberies, kidnappings, all the terrible stuff. Over time and exposure, that can provoke a sense of fear in a person. Does TV make people feel more at risk, or do anxious people watch more news? Or is there some third variable? So in what way, so when we think about this right here, we're asking ourselves, what is the directionality of the relationship? Perhaps elderly people are more anxious about their lives and have more time for TV, or perhaps elderly people are watching TV and then become more anxious about their lives. So depending upon differences in ages could affect differences in anxiety levels. Another example of research we might see, do people who watch a lot of TV as children become more violent later in life? You could employ a longitudinal study to determine that, to see that if you were a child and watched hours of cartoons later in life, were you more or less likely to be violent? Then we have to define what violence means. In an experiment, we assign people. We assign them to a random, we randomly assign people to different conditions or situations. If we do this, we get to make inferences. I want to say that again. We assign people to random conditions. We get to make inferences about how different conditions affect their behavior differently. So an example might be the Stanford Prison Experiment. We assign people as either one role or another role, and then we look to see what happens. Remember, we want the groups to have little bias. So therefore, we need random assignment. We also want to manipulate variables. We want to change a variable and see what happens to the other variables in the study after we do that. When we talk about variables, I want you to write this definition down word for word. Variables. Any property or characteristic of some event, object, or person that may have different values at different times depending upon different conditions. And variables could be continuous. So there could be an infinite number of values. It could be anything. So height, weight, time. Or they could be categorical. So a thing either is or it isn't. You know, you have those studies that say the average American family has 2.5 kids. Well, you can't have 0.5 of a kid. If you are out in public and you see a family carrying 0.5 of a kid, you need to call the cops. Multiple crimes took place, multiple human rights abuses happened. Either you have 2 kids or you have 3. So categorical means there's not an infinite number of spaces between values. There's independent or predictive variables, which is the variable you manipulate. There's dependent or criterion variables, the variable that changes as a result of your manipulation. You must randomly assign participants to the condition. This makes it so that each person is as likely to be in one condition as another. It also ensures that except for manipulation of the IV, there are no differences. In other words, things remain mostly the same except for the level of the independent variable to which a person is assigned. Studies must also have a control condition, which means it's the normal condition. it lacks the change in the independent variable. Here is a study that I have written down. I won't read it word for word, but you can look at it on the lecture to get a sense of what it means to have, design, and analyze the results of an experiment. Other concepts, validity. So there's external validity and there's internal validity. External validity means that your findings apply to the real world. Internal validity means you have control over the laboratory settings in which you are doing the experiment. Measures must be reliable and valid. Reliability meaning you test it over and over again, and you have the same findings. Validity meaning the thing you're testing is actually what's being tested in the study. And then statistical significance. Your p-values. Is it significant at the 0.05, the 0.01, the 0.001? In other words, is there only a 5% chance or less that your findings were due completely to chance? So, external validity, an experimental setup that closely resembles real-life situations so that results can safely be generalized to such situations. In other words, the findings apply to the real world as we know it. And then internal. In experimental research, confidence that only the manipulated variable could have produced the results. It was only the change that I did that caused this change. I had such control over my laboratory that I was able to ensure that the change was what I manipulated. External validity and internal validity have an inverse relationship. They have an inverse relationship. The more internal validity you have, the less external validity you have. The more tightly controlled your study is, the less likely you can apply the findings of that study to the real world. Why? Because the real world is chaotic. There's chaos there. And you have your study and you have everything completely set in your laboratory, but the more you have control of the laboratory, the less it resembles the real world. Reliability. The degree to which a particular way that researchers measure a given variable is likely to yield consistent results. You want high reliability. So if you have a measure, for instance, you want it to have the consistent scores across time and across people. So if you take an IQ score twice, do you get the same score? Measurement validity is the correlation between some measure and some outcome that the measure is supposed to predict. So if IQ predicts academic performance, then the test that measures IQ can be said to be valid. Are we measuring appropriately and adequately the things that we said we would? Types of statistics. There's descriptive stats. So we analyze to describe a situation. So we just spoke about some. There's inferential. When we want to obtain the sample data in order to make inferences. So descriptive stats describe, inferential stats help to make a prediction. Your inferential statistics are where you're going to encounter your p-values. And that is it for today. So I already have the ethical concerns uploaded. And I will see you wonderful folks in a little bit.